This is Unit 1, Objective 2, talking about translations. So we have our essential question again. How do you use translations to graph parent functions? So translations is moving left, right, up, and down. So our key point is not going to be 0, 0 every time anymore. That was the parent function. Now we're going to be moving it around. First thing, just real quick, how to solve for y. A lot of people forget. It's been summer, had some all that good stuff. So we're going to get this equation solved for y. So we're going to subtract 2x from both sides first. We want it usually in the form of y equals mx plus b. So I'm actually going to change the order here. So it's negative 2x plus 15, because that is a positive 15. And then I'm going to divide by negative 5. Remember, we divide everything by negative 5. So this side, negative 5 divided by negative 5 is positive 1. Negative divided by a negative makes a positive, so it's positive 2/5 x. And then 15 divided by negative 5 is negative 3. And so that is solve for x. So that would be a line with 2/5 slope and a negative 3 shift. Okay. So next, we're going to talk about our shifts. We have 4 shifts. We have up, down, left, and right. Okay. So if you have your function, and at the end is plus a, that would be up a. So a represents some number. It could be 10, it could be 12, whatever it is. Okay. If it's minus, so it's the function, and at the very end minus a, that is down a. Next two, notice these are inside the parentheses. So if you have a function and in parentheses, right next to the x is a plus a, this means we're going to move left a. So you got to be careful. A lot of people get these two mixed up. You kind of think opposite. Left is the negative direction, but when it's in parentheses, you got to think opposite. So when it's in parentheses and it's plus, that's a left shift. In parentheses and it's a minus, that is a right shift. Right. So these are the parent functions we're going to be dealing with. We have f of x, g of x, h of x, j of x, and k of x. F of x is just some crazy looking function. And then we have a line, quadratic, linear absolute, and exponential. So the first thing is, what if we took this function and did plus 3? So that's to the end. So that's an up 3 shift. So I have these drawn on my graph already. All it means is we literally take each point and move it up 3. Everything else, the general shape, looks the same. So it kind of looks like this, curve, curve. Everything else looks the same. Okay, so 3x is our normal function. So I'm just subtracting 4 at the end. That's a down 4. So I'm going to take each point, move down 4. Everything else looks the same. So draw it like that. Okay, now our normal function is 3x squared. Notice now inside the parentheses I have a minus 4, so that is a right 4 shift. I'll fix that. Okay, so 1, 2, 3, 4. The shape looks the same though, so it's still quadratic, just shifted right 4. And this one, that is, we took the function, and it's not parentheses, but you can kind of think of absolute values as the same idea as parentheses. It's only affecting the x, so it's a plus 2. That is a left 2 shift. So we take each point, 1, 2, 1, 2, 1, 2, and then keep the same shape. Okay, so the blue one is technically the graph, right? I'm using the pre-drawn one here to help me shift. Okay, and then we could do the same thing, but now we have multiple things happening to each one of these. So this one we have a right 2, down 3. So 1, 2, 1, 2, 3. 1, 2. Just take each point and move it. That's kind of what we're going to do to our, so this is left 2, down 3 now. So when we talk about our key points, this is what we're doing to each key point when we have translations, the pluses and the minuses. So this is right 3, up 2, and finally, so this one doesn't have parentheses, but in the exponent, notice it's only affecting the x, so you can kind of think about it as having parentheses right here. Okay, so I'd say left 1, up 4. One thing you want to notice is I am going to actually move the asymptote. You can't really move an asymptote left and right. It's going forever in both left and right. So if I moved this line left 4, it would still be the same spot. It's the up and down that really matters. And it's important to shift it because we can't cross it, right? So it helps us get our graph right. Okay, so there's our shifts. So next we're going to talk about composite functions. This is f of g or g of f of x. We got to follow what it's telling us to do. Notice this is telling us to plug g into f, right? If I told you f of 4, that means you're plugging in 4 for x. So now I'm plugging in this function into this function. The other one, g of f of x, means I plug in f of x into g. Okay? So this is telling me to plug g of x into f. So I'm taking this whole thing, plugging it into f. So that would be x minus 4 squared. Quantity squared within parentheses. The whole thing is squared. That's important because when we shift our function, we take our key point, which this is quadratic, so our key point is 0, 0, and we shift it right 4. That's our shift. So I'm going to go here, 1, 2, 3, 4. Then we follow our a is 1. So we follow our 1a, 3a, 5a pattern. So it's 1, 3, 5. We take our key point. When we go from our key point, we go over 1. I'm going to go up 1 in this case. Over 1 more, go up 3. Over 1 more, up 5. And then we mirror it from the key point. So over 1, up 1. Over 1, up 3. And we have our function. Okay. Then we have our next one. This is f of g of x. So plug g into f again. So I'm going to take this and plug it in right there. We plug in for the variable, right? So my new function is 3 to the x minus 1 minus 2. This one's exponential. So you got to remember our key point in exponential is 0, 1. But now we got to shift right 1 down 2. So I'm going to go to 0, 1 on my graph, and I'm going to shift right 1 down 2. Okay, and we got to do the same thing to the asymptote actually as well. So my asymptote is usually y equals 0, but I got to shift it. So my y equals 0 is a horizontal line right here, and I'm going to shift it right 1. That doesn't do much, but down 2 moves it down. Okay. And remember, the easiest way for exponentials to get new points is plug in things. So I'm going to plug in, you go to this key point and go to the x value right to the right of it. So that's 2, and I'll plug that in. So I get 3 to the 2 minus 1 minus 2. So that would be 3 to the first minus 2. which is 3 minus 2 or 1. I could plug in the next one over if I wanted to, so that would be 3 to the squared minus 2, so that would be 9 minus 2, which is 7. Might not fit on my graph. We'll see. So I have 2, 1. 1, 2, 3, 4, 5, 6. It does just barely fit. Okay, so I know I'm not going to cross, and then I spike up. Oops. Okay, and spike up. Boom. And there's our new function. Okay, last one of this type. Plug in f into g. So plug in my f into my g. Oh, luckily this one's a little easier. Absolute values are a lot easier to deal with. Okay, so we get our key point, absolute value function. Our key point is 0, 0. And we look at our shift, right 4 up 2. So from my key point, I'm going to go right 4, up 1, 2. Okay. Then we look at our a value. Since it's linear, we can think of it as slope. So I'm going to use slope. I know it's opening up because it's a positive value. Got to remember that. So up 1, 2, 3 over 1. And remember, it's a mirror image for the v. And there we go. All right. Last thing, we're going to describe translations now. So we're going from f to g. So how would I get from the f of x graph to the g of x graph? So I'm going to graph f of x as blue, g of x is green for this one. Okay, so these are linear functions. That's nice, easy to graph. Okay, so for f of x, I have a right 3, down 4 shift, and a slope of 1/2. So we start at our key point, 0, 0, right 3, 3, down 4. And then we follow our slope, up 1 over 2, up 1 over 2, and that's f of x. And make sure you label it. If you have more than one graph, you gotta label it. Okay, now you get the green one. So this is a left 2, up 3, with also a slope of 1/2. So start from my key point, 0, 0, left 2, up 3, 1, up 1 over 2, up 1 over 2. Always have it 3 points, g of x. Okay, now I just need to describe my translation. So I'm going from f, make sure you're careful, from f to g, and make sure you have a common point. So I'm going to use the point we shifted to here. So how would I get from this point to this point, basically? So it's left 1, 2, 3, 4, 5. And then up 1, 2, 3, 4, 5, 6, 7. And that's it. And don't worry about notation. You can cross that out. Okay, so then we get to the other one. This one's a little harder. But this is our last one on the notes. So this is quadratic with a negative value. So make sure it's opening down. So this is a left 2, up 3 shift for the f of x. And a equals -1. So that would be -1, -3, -5 for my pattern. Okay, so we always start at the key point though. So start from 0, 0, left 2, up 3. Remember, it's opening down, it's negative. So when I go down 1, or sorry, when I go right 1, I go down 1. From that point, right 1, down 3. And then from that point, right 1, down 1, 2, 3, 4, 5. I could put this point. I'm not going to though. And then mirror. And we have our f of x function. Okay. Then we get to g of x. So this is a right 5, down 1. This is also an a value of -1, so we have the same pattern to follow. Remember, if you have trouble with the pattern, plug in points. Plug in x values. Start with your key point. Shift to that point first. So you'd plug in. So I'd get to my key point. So I go right 5, down 1. And then you'd plug in the x value to the right. So that would be 6. And the x value to the left, 4. So those would be the two x values you'd plug in. X value of 4, x value of 6. Get the y value out, and you'd have your next 2 points. I like the pattern though, so I go right 1, down 1. And I go right 1 more from that point. Then I go down 3. And then I mirror it. Think of that pattern's really easy to work with, makes things quick to find. Okay, now we got to describe from F to G. So always go to your key point. It's just a lot easier. So I'm going to go right now. 1, 2, 3, 4, 5, 6, 7. So right 7. And down 1, 2, 3, 4. And that's describing the translation. Don't worry about the notation. Okay. So you're going to answer your essential question for your summary. Remember, 3 sentences minimum.